Now we're going to proceed with the two numerical solution methods that we're going to discuss for today. All right, so we just close off the Canon here. I'm going to move over, okay, to the second tab that we have here. So this is the use of the fixed point iteration method. So this is a numerical analysis approach. It's an iterative method to determine the roots of a particular algebraic expression. Okay? All right. So how do we do that? How could we uh, determine the roots of an equation? Okay, so how do we do that, guys? Well, if you have your calculators, actually, you could just solve it right away, especially if it's made up of first order, okay, or even quadratic equations or cubic equations. The calculator could easily solve that. So, for example, we have here an algebraic expression or equation, and it says x cubed, okay. So once again, x cubed minus 3x squared minus 16x minus 12. So it's a cubic equation. So it's x cubed. It means we could be having how many roots? We have 3 expected roots for this particular equation. Now, I have shown you earlier the calculators that we could use. So I'm going to show them again and see what are the roots of this particular equation. So for example, so here in the Casio calculator, we simply go to equation, all right? And then let's go over to the fourth here because this is a cubic equation, just so that we will know the roots, okay? We could determine the roots of this equation. So we have here x cubed, so the coefficient would be 1, and then negative 3, we have negative 16, and negative 12 here, okay? And if you're going to press on equals, you can see here the roots. We have 6, we have negative 1, and negative 2. Okay, so take note of that. 6, negative 1, and negative 2. If we're going to use your Canon calculator over here, so we simply go to equation. So we have 3 unknowns. So the beauty of the Canon calculator, guys, is it could even solve up to 4 unknowns. Okay, so a system of equations in 4 unknowns. But we're not interested in the unknowns because we already have x here. However, we have a cubic equation. So we press on the down key, select the cubic equation, that's option number 2, and we're going to input our coefficients. Once again, it's 1, and then negative 3, we have minus 16, and we have negative 12 as well. So this will solve the roots for us. So 6, negative 1, and negative 2. Okay? Now, for you to have an idea why is this necessary, we're going to consider a numerical analysis approach. This is actually what happens when we do shift solve. Are you familiar with shift solve? All right, the shift solve function that we have. All right, so this is the shift solve function, x cubed. Okay, so minus 3x squared. This is how we solve for the roots. Okay, just by using shift solve. So 16x and then minus 12 equals 0. So if we shift solve, it will ask us to set an initial value for x here. So say for example, we're going to set an initial value. Take note, the roots that we have are 6, negative 1, and negative 2. All right, that's what we had when we solved this using the equation function. So for example, we're going to set it to 5. Of course, it will give us the root nearest to 5, which is 6. If we're going to shift solve and then set the initial value 0, then it will give us negative 1. And if we shift solve and we set it to negative 5, and it would give us negative 2. So it will give us the 3 roots, depending on the initial value that we used. So the calculator, Casio calculator, or the Canon calculator actually uses a numerical analysis method in order to solve for the roots. And it's actually using the Newton-Raphson method or the Newton's method, which we're going to show you later for our discussion. Okay? So the first analysis that we're going to use and how to solve this is the fixed point iteration. So let me just hide our calculators here. And how do we do this? So this is the given, guys. The fixed point iteration needs us to come up with an expression of x. Okay? So we could come up with three equations or expressions of x by simply isolating one of the terms. So for example, I'm going to isolate x cubed, transfer everything here to the right. So this will now become x cubed minus 3x squared plus 16x plus 12. Okay? And then expressing this as x, we need to have it expressed in terms of x. As the only variable x on the other side. So x, since this is x cubed, so it'll become x cube root of 3x squared plus 16x plus 12. All right. Now, here I have already actually, because I did the calculations earlier just so that I could test the results. But this is how we do it. N here is actually the value of x. So let me just change this to x because it would be better if we'll have it set as x. So actually, we test the value of f of x. We test the value of the entire term here by substituting first negative 10. So we substitute negative 10 as the value of x, okay, over here. And then this now becomes our next value for x. So here, this is a test value, a trial value. So it's our first initial value, so negative 10. And notice the expression here, right? This is equal to the quantity 3b26. What is b26? So this is actually x. We're actually following the equation. 3x squared plus 16x plus 12. So that's 3 times b26. Notice the formula bar up over here, guys. All right? 3x squared plus 16x plus 12. And then we raise this to 1/3 because it's cube root. Okay? All right. So that's how I did it. And then basically, this value here is simply equal to this value. Okay? And then what I'm going to do is simply autofill. So extend your cursor over to this right corner and then scroll down. All right? So it will now give you another value for f of x. And then the two of this, select the two cells, select on the autofill toggle, and then scroll all the way down so that it will iterate over this values for x that we have substituted. Okay, when we say iteration, it repeats over and over until it converges. It reaches to a final value, and that value is 6. And take note, 6 here is actually a root, right? It's one of the roots. 6 is actually one of our roots. Okay, so if I changed our initial value, say for example, I changed this to 5, so the root that it could get is, of course, 6. If I change this to 0, it will also give us 6. If I change this to -3, it will give us -2. So this is actually an initial value. All right, this is an initial value that we plug in to the formula, and it will iterate. Once again, the process here, first it substitutes -3 to the entire equation, and whatever the value here becomes the new value for x. Solve for x again, this becomes the new value of x. Solve again, this becomes the new value of x until it converges, meaning it will have the same value. Okay? It will now have the same value. Okay? So, once again, we started with, what was that, -10. The answer here was 6. And say, for example, we say 0 as our initial value, we'll get 6 as well. If we have -5, it's also giving us 6. If we have -3, it gives us -2. Now, what about -1? All right, we actually have a value of one of the roots as -1. Well, when we use the fixed point iteration method, we could actually get another expression of x. How do we do that? Here. So say for example, we're going to isolate the second term. So we transfer 3x squared over to the right side. So it becomes like this. X cubed minus 16x minus 12. And then I then express everything in terms of the sole variable x. So that would be over 3, divide first by 3, and then take the square root. This is now the resulting equation here now. So the f of x here is now the square root of x cubed. This is now the x, f26. So x cubed minus 16x minus 12 over 3. And then this is a square root because it's a squared symbol. Or you can also have it raised to the 1/2. Okay? Raised to the 1/2. So this is our initial value. And then this is our value for x when we substitute the value of 20. And then this will now be, the new value of x is this value of x. And then we perform the operation again, and so on and so forth until it converges. So I have set here a trial value of 20. Let's just try different values of 10. Different values of x. So say for example 10. All right. So I'm going to click on 10 or set it to 10. You see here it becomes hashtag num because it becomes a very, very big or very, very small number. So it doesn't work. It doesn't give us a root. Say 5 doesn't give us a root either. What about 4? It doesn't give us a root. 2 will not give us a root. So this will only be possible for big values. 30, for example, doesn't give us a root. 60 doesn't give us a root as well. So there are times when the fixed point iteration actually will not give you a root for the expression of x that you have used. Okay? So in this case, we cannot get any root out of this. Now we proceed to the other expression of x that we can use. And this time we isolate 16x, this one. We transfer 16x to the other side. This is what it becomes. And then we divide by 16 so that, because it becomes 16x. So we divide by 16 and we input that here. So this becomes x cubed, where the x is actually the value for K26. X cubed minus 3x squared minus 12 over 16. Okay? So we start with 0. For example, I test the value of 0, and it now gives us negative 1 for our root. If I try to get to use 5, it still gives us negative 1. If I use 10, it won't allow us to use 10. If I will set it to negative 5, it won't allow us as well. Negative 4, it won't allow us. Negative 3, no value here. 0, only negative 1. Okay? 2 will give us negative 1. Okay? 3 will give us negative 1. 4 will give us negative 1. So as you see, the fixed point iteration doesn't immediately give you the results here in Excel, but with the use of with the use of the method that we have introduced here, and by changing the initial values, you could now determine the roots. So we have negative 1, negative 2, and earlier if we use 10 over here, it will give us 6. So we have 6, negative 1, and negative 2. The second equation did not yield any roots at all, so we simply just neglect the results that we have there. We're not interested in those. Okay, so that's for the fixed point iteration method. All right. We'll now go over the next method that we have here, and this is called as Newton's method. All right, so I'm going to show you how we could also do this with the use of Excel. And we have used the equation that we have also solved using the numerical analysis method of the fixed point iteration. All right, so with fixed point iteration, we solve for the roots of this. We actually solved it using the calculus first, and we got those roots as well. Okay, so what is the Newton's method, and how can we use Excel to get the value of x for this? So this is how we do it. So this is how Newton's method is presented. So it says here that the next value of x, because we start with an initial value of x, okay? We start with the an initial value of x that will be up to us. It's up to us what initial value that we're going to use. So when we do shift solve in a calculator, that's the initial value that we input. That's actually the initial value of x here. Okay. So the calculator actually uses this principle. Okay. So the new value of x is equal to the old value of x, the previous value of x, the assumed value of x, or the initial value of x, minus f of x of n and over f prime divided by f prime x of n. So when we say f prime, this is actually the first derivative. Okay? So here, this is our equation. The first derivative is 3x squared minus 6x minus 16. Okay? 3x squared minus 6x minus 16. So I hope you already know your differential calculus. This is just using very basic differential calculus. 3x squared minus 6x, no? Okay, and then minus 16. So the constant will no longer be included. Okay, so here I have set the initial value of 5 and f of x here, notice. I'm actually following how it is presented here, guys. Alright? I'm actually following how it's presented here. So this is now B17. B17 is x of n. This is my old value of x or the initial value of x. Minus, I am now substituting the value of f of x here in the original equation. So that becomes x cubed or B17 cubed minus 3. This is our x. 3x squared minus 16x minus 12. Divided by, I'm also using here the f prime. Okay, so that's 3x squared minus 6x minus 16. Okay, so this is now the result. Now, this is iterative. So this will now become the new value of x. So notice, I just equate that to C17. Alright, I equate that to this value. And then this one, I autofill. And then this one, I autofill down below. Okay, so we have our first result, which is 6. If I'm going to set the initial value to 0, it will give us negative 1. If I set my initial value to negative 5, it will give us negative 2. So really very easy to apply the Newton's method. All we need to do is apply the first derivative or to determine or to express our expression in terms of the first derivative and use that to solve for the roots. Okay? So any expression can be solved here, no? Using the Newton's method. So really very easy to use. Okay, you might in your study in college or you may have learned other numerical analysis methods such as the second method, regular fallacy method, and the bisection method. But this is actually the easiest to apply, the easiest to perform, the least complicated way to solve for roots. Okay? It's called the Newton's method. And anyway, there's a prerequisite here because you have to have a foundation on differential calculus because you are going to differentiate it. Here it is just an algebraic expression in terms of x, but what about if you have trigonometric functions, hyperbolic functions? So you should have knowledge as well how to differentiate those functions. And still, you can solve for those values of x using this iterative method. All right. So thank you so much for your time. I hope you've learned something over here. And I'm actually going to attach this file or place a link in the description of this video so that you could have a copy of this Excel file that I have created so that you could play with it and you could also experiment on it. All the formulas will be here. You could try it for yourself and you could try solving other equations using these two methods that I have shown. All right. And I've also mentioned in the first part of this series of videos, I think that was part 1, how we could use Wolfram Alpha. So let's just go over there and try how we could also use that very useful web application or website. Let me just show it here for a while. Where do we have that? All right, here. So let me input our equation here and let us see how it could solve for the roots, how powerful the website is in solving for roots. So I'm going to have here solve. we have, what was that expression? Let me just copy over the expression. So it's x cubed minus 3x squared minus 16x. So x cubed minus 3x squared minus 16x minus 12 equals 0. This is the equation. Let me just double check. All right. So this would be, once again, okay, 3x x cubed minus 3x squared minus 16x minus 12. And as you can see here, it automatically shows us the roots, guys. So you see here how fast it does it for us. It even has a step-by-step solution, although you couldn't see everything because you need to to buy, okay, to upgrade to Pro in order for you to do that. But it already gives you the results. Okay, it gives you a hint on how to do it. You can even just factor it out, as you can see over here. It can even show you the plot and the positions of the roots on the number line. Very easy, guys. I hope you've learned something, especially with this wonderful tool that we have here in solving mathematical problems. The free website, free web application, Wolfram Alpha. All right. Thank you so much for your time, everyone. I hope you're having a good day. Enjoy the rest of the day, and please don't forget to also follow us here and hit like on this video. Thank you so much for all your support, guys, and till next time.